Hi, good morning. Good morning, good morning, good morning. Yeah, good morning, good morning. So everyone Manchi, yeah, okay, good morning, good morning, good morning. Yeah. So everyone Manchi at home. Yeah, okay, very good, very good. I'm also good, no problem. I'm also good. I'm also good. So what's going at home? Chilling or studying? What's going on? Studying, sir. No time to chill. Now less than 4 months are left now. Yeah. So chilling with studying. Some people are saying, sir, chilling, but I know if you are saying chilling means you are chilling with studying. Yeah, okay, no problem. People are asking about shuffling. Shuffling not happen. Next week, I think shuffling will happen. Okay, no problem. Yeah. Okay. Yeah, it's too hot. In Vijayawada, temperature has suddenly increased. In Vijayawada, temperature has suddenly increased. It's crossing around 50 degrees Celsius. Yeah. Uh, yeah. Okay. Okay. No problem. Yeah. Okay. Okay. So now let's start with the class. Now let's start with the class. Yeah. Okay. No problem. No problem. And I think in last class we were talking about relation between latitude and angle of dip. Yeah. Okay. And there I was telling you tan delta will be equal to 2 times of tan lambda. Yeah. Okay. 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 No problem. Yeah. So everyone remembered. So just I will tell you the important results that we got. We got relation between true dip and apparent dip. Tan delta dash will be equal to tan delta by cos theta. There I was telling you if you know two apparent dip, you can find true dip with the help of one result. Cot square delta dash plus cot square delta double dash will be equal to cot square delta. Then I was telling you one relation between angle of dip and latitude, that is tan delta will be equal to 2 times of tan lambda. So I was also telling you at the poles your delta will be 90, at the equator your delta will be 0. Everyone remembered all these things? Everyone remembered? Yeah, okay, 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 very good, very good. Yeah, okay, no problem. Now today we'll be talking about one more part. One more thing I'll be talking. I was telling you earth magnetic field will have two components. One will be horizontal component BH. BH will be equal to B cos delta. One will be vertical component BV. BV will be equal to B sin delta. Tan delta will be equal to BV by BH. Net magnetic field will come under root of BV square plus BH square. Now all these questions are asked. Very simple questions are asked from here. Okay, no problem. There I was telling you northern hemisphere, our dip will be positive. In southern hemisphere, dip will be negative. Yeah, okay, 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 very good. Yeah. So all these things we studied in last class. Now we are going to talk about third element. And already we have studied about third element. You write. Horizontal component of Earth's magnetism. In bracket BH. That is our third element. Horizontal component of Earth's magnetism. Horizontal component of Earth's magnetism. That is our BH. And we already know value of BH. BH value we are already knowing that BH will be coming as B cos delta. This is the value of BH, which we already know. This is our third element. That is horizontal component of Earth's magnetism. That BH will be coming as B cos delta, where delta is our angle of dip. Now understand. Okay, so this is, yeah, okay, so this is all about our third element. Since we already studied, so that's why we don't need to know more about the third element, that is horizontal component of Earth's magnetism. Now understand, we focused one type of question exists here. And I am telling you third element BH only for this type of question. So be focused, bring understanding. Understand how we'll be talking about. Yeah, okay, no problem. Now understand. Yeah. Now we'll be talking about, yeah. Ooh, okay. So BH will be coming as there is no relation between dip and declination. Both are two different things. Yeah. Now be focused. So BH will be coming as B cos delta. Okay. Now understand. Now understand. Acha, can you tell me what is direction of BH? In which direction Earth's magnetic field is always pointed? What is the direction of BH? BH is horizontal. Horizontal, yeah. Earth magnetic field is oblique. I'm talking about horizontal cover, but this horizontal will also have direction now. This horizontal may be towards east, this horizontal may be towards north, this horizontal may be towards south. What is direction of BH? Yeah, BH will be always directed towards north. Not exactly. If you remember, exactly north will not come, but approximately you can write this point. You write BH is always directed towards north. BH is, yeah, geographic north. Yeah, obviously geographic north. BH is always directed towards north. In bracket, approximately, not exactly north. BH is always directed towards north. In bracket, approximately. Exactly north will be not there. That is why you get angle of declination. If you remember, that's why we get angle of declination, because magnetic compass needle never points true north south direction. Magnetic compass needle comes under effect of BH only. So BH will be approximately towards north. So always remember, direction of BH will be always towards north, but not exactly, approximately. So this is how we talk about this point. And from here, one question is asked. I am interested in that question. You write this part. You write neutral point in bracket null point. Null point is also known as neutral point. Neutral point in bracket null point due to BH and a bar magnet. Neutral point in bracket null point due to BH and a bar magnet. What is meaning of null point? What is meaning of null point? Yeah, the place where net magnetic field will be 0. That is our null point. Yeah, okay, no problem. Yeah, neutral point in magnetism, we say null point also as neutral point. Neutral point is also known as null point. So we are going to talk about null point with the help of BH and with the help of bar magnet. How question will be asked? First see the question, then I will talk about. Just see. Actually, what will happen? They will say you there is a bar magnet. You know already everywhere magnetic field will be there now. Everywhere Earth's magnetic field BH is present everywhere. And if you put one bar magnet, that bar magnet will also produce magnetic field. If magnetic field of BH and magnetic field of bar magnet both cancels each other, what will be the net magnetic field at that point? Yeah, net magnetic field at that point will be 0, and we will get null point. We will get neutral point. So they will ask you to find location of null point. They will ask you where null point will exist, whether null point will exist in east-west direction or whether null point will exist in north-south direction. Then they will ask you from the magnet at what distance null point will exist. So understand how we'll be talking about. Be focused. Just see here. Yeah, how question will be asked. Questions are asked from two special situations. They will say you like this. They will say you a bar magnet is placed. They will say you one bar magnet is there. This bar magnet is placed such that north pole of the bar magnet faces north direction. North pole of bar magnet, somewhere here you will be having north direction. So they will say you such that north pole of bar magnet faces north direction and south pole of this bar magnet faces south direction. The question will come like this. A bar magnet is placed such that north pole of the bar magnet faces north direction, south pole of the bar magnet faces south direction. You know, if these are north and south, here we will get west and here we will get east direction. First you draw this diagram. Then we will talk about how to obtain null point here. Little conceptual part, your understanding will be required. Then only you'll be able to understand what I'm trying to tell here. Yeah, okay. So I'll be simply saying, okay, sir, what they will say you like this. Yeah, one bar magnet is placed such that north pole of bar magnet faces. Who is saying north repulsor? This is north direction. This is not hey Bhagwan. Someone is saying, sir, this is north and north repulse. But this is north direction, this is south direction, west direction, east direction. Okay, no problem. Now understand. They will say you like this. A bar magnet is placed such that north pole of bar magnet faces north. South pole of the bar magnet faces south. They will ask you at which location null point will exist. Whether null point will exist in east-west direction, whether null point will exist in north-south direction, whether no null point will exist. Just see how to find location of null point. I will simply say, okay, You'll be simply saying, okay, sir, we'll talk about magnet. But first, let's talk about Earth. You know, Earth's magnetic field will be always present everywhere. Everywhere you'll get BH. In which direction BH will come? BH will always come towards north. So here also BH will be there. 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 Everywhere Earth magnet is there or not doesn't matter. Earth will be always there now. So Earth will always produce magnetic field at every location. Whether you are talking east, west, north, south doesn't matter. And direction of that Earth's magnetic field will be always towards north. So here also BH, here also BH, here also BH, here also BH. You tell me, in order to get null point, this magnet should also produce field now. And in which direction this magnet should produce field? You tell me, in order to get null point, in which direction this magnet should produce field? Yeah, it should produce field opposite to BH. Opposite to BH. Yeah, if you observe that, you can get from here. Just here, I'll be simply saying, okay, sir, you said about Earth's magnetic field, BH, BH, BH everywhere. But this magnet is also there now. Look at the magnet. Its magnetic dipole moment will be from south to north. And these positions will be your axial position. This position now, north and south, is your axial position. You tell me, on axial position, which direction magnet produces the field? In the same direction of dipole moment. You see its dipole moment is like this now. So here it will produce magnetic field in the same direction of dipole moment. Here also it will produce in the same direction of, look at the dipole moment. Your magnet will produce magnetic field in the same direction of dipole moment, same direction of dipole moment like this. So here it will produce like this. Here also it will produce like this. And tell me, on equatorial position, look at east and west. East and west are equatorial, opposite to the dipole moment, opposite to dipole. This is dipole moment. So here in east and west, which are equatorial, magnetic field produced will be opposite to dipole moment. Dipole moment like this. So opposite to it. Opposite to dipole moment. Now you see and tell me where possibility is to cancel the magnetic field. See the diagram and tell me where it is the possibility. Yeah, east west. So always remember, in this situation, if your north pole of magnet faces north, you'll get null point will come. Null point. We are going to get null point, sir. We are going to get null point in east and west direction. We are going to get null point in east. You can see the diagram. And you'll be simply saying, I can exactly find the distance also, sir. I can find this distance. At what distance this null point will exist, I can find. Because I know for null point, this B is due to equatorial. If you see here, this B is due to equatorial. So I'll be simply saying, sir, if we are getting null point, that means this B equatorial must cancel BH. And B equatorial you have studied, Baba, mu naught by 4 pi m by r cube. This will be equal to BH. In exam, they will give you all the values. You can find r from here. First write this, come on. And you cannot remember this. That's why understanding is important. Vertical is not any element. We don't talk about vertical component. That diagram is nice, I know. It's so easy. So everywhere BH, 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 BH now. One magnetic field this magnet will produce. I know this is axial. On axial, magnetic field produced will be the same direction of dipole moment like this. So here also like this, here also like this. This is equatorial, opposite to the dipole moment. So from there we can get. I will give you one more question. Come on. Next situation you do. Right. A bar magnet is placed such that its south pole faces, a bar magnet is placed such that its south pole faces north direction and north pole faces south and north pole faces south. Find location of null point. You have to tell me whether null point will exist in east-west or whether it will exist in north-south. Yeah. Patnaik, very good. Yeah. Sneita, very good. Prashanti, very good. Yeah. Soni, very good. I think everyone is getting idea. Yeah. Again, before doing anything, one magnetic field, you know, magnet there or not there doesn't matter. Sir, everywhere Earth will have its effect. Earth will have its magnetic field. BH, BH, BH. Everywhere BH is there. Okay, no problem. But I know, sir, magnet is space now. This magnet will also produce magnetic field everywhere. This is the dipole moment of the magnet, sir, from its south pole to north pole. Now, if you see, these positions are axial. And you know, on axial, magnetic field produced will be the same direction of dipole moment of the magnet. Dipole moment of the magnet is like this. So here magnetic field produced will be like this. That is axial. Here magnetic field produced will be like this, in the same direction of dipole moment. That is your axial. And these are equatorial position. Look at there, Baba. Use little bit of your brain. Kuncham burra kawali. Use it. Sir, here dipole moment like this, these are equatorial. On equatorial, I know magnetic field produced will be opposite to dipole moment. Dipole moment like this. So magnetic field produced will be like this. Magnetic field produced will be like this. This is the B which will be produced, sir. So we will not get null point in east-west. You can see here, chances of magnetic field to cancel is there. That means we'll be saying null point will come, sir. Here, if you talk about null point, here null point will come in north and south. If anyone asks you to find distance of that null point, you can say for null point, this B of axial must cancel BH. So it must be equal to BH. B axial, you know, mu naught by 4 pi 2m by r cube. This will be equal to BH. Chamki baat? Everyone understood? Did you understand? Yeah, okay, okay, very good. Are bolo, everyone understood? Yeah, okay, okay, yeah, okay, very good, very good, very good. Yeah, yeah. I'm giving you time of 15 seconds, see both situation. We'll move to the next part. North facing north, null point will come in east-west. South facing north, null point will come in north-south. If you want to remember, but you will be able to remember for few days only. So go with the concept, go with the diagram. That will help you if question will come in your NEET exam. Who is sending a smiley? No, one is sending like this, laughing, oh, yeah. Okay, no problem. So this is how we have talked about. Now we'll move to the next part. We'll be moving towards next part. Yeah. Earth magnetism, IPO. Now we'll be starting with next part. Be focused, understand. Yeah. Okay. 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 No problem. Yeah. Now what will happen in next part now? Actually, next part is slightly confusing. So your 100% focus will be required. Then only you'll be able to understand. Actually, names will be very similar. Very similar names will come. For example, yeah. Oh. So names, what names will, sir, go, be focused here. Yeah. So what will happen here? Our names will be going to be very similar. Same type of names will come everywhere. So understand how we'll be talking about this part. Yeah. So first you have to understand the names. Then you have to understand what is meaning of these quantities. You write properties of magnetic material. Properties of magnetic material. We'll study different type of materials later on. First, we'll understand this part. This part will help us to talk about different types of material. I think you have studied about different type of material, na? Diamagnetic, paramagnetic, ferromagnetic. Yeah. So before that, one part is there, and that part is very conceptual. That part is little confusing also. So your 100% focus will be required. Then only you'll be able to understand. Now be focused, understand. I will be talking about. We are going to talk about some quantities that we will study here. So first quantity is, you write, first you write magnetic intensity. Magnetic intensity. In bracket, this is one name. Magnetic intensity. In bracket, intensity of magnetizing field or force. Magnetic intensity. In bracket, intensity of magnetizing field or force, intensity of magnetizing field or force represented by H, capital H, magnetic intensity, or second name intensity of magnetizing field or force represented by capital H. Now understand how we'll be talking about. Bring understanding, otherwise you'll not get any idea what I'm trying to tell. Be focused, understand this here. Always remember, every body has magnetic property, but it don't show magnetic property because that properties is random. Understand what I'm trying to tell. Be focused. For example, if you look at this object, this object also has magnetic property. Yeah, if you look at this, if you look at this object, now this object will have magnetic property, but it will not show that magnetic property. If you want to show, if this body wants to show its magnetic property now, you have to apply some external field. Always remember, every body has magnetic property, but they don't show magnetism. If you want to develop magnetism in the body now, you have to apply external field. And associated with that external field, we talk about this quantity, which is known as magnetic intensity. Look at its second name, intensity of magnetizing field or force. That means field which is trying to magnetize the body, the field which is trying to produce magnetism in the body. So always remember, you write this point. It is associated with external field. It is associated with external field which tries to produce, it is associated with external applied field. It is associated with external applied field which tries to produce magnetism in a body. It is associated with external field, external applied field, which tries to produce magnetism in a body. So always remember, you tell me, if you want to produce magnetism in the body, will it produce by itself? Will it produce by itself? No. For that, what you will do? You will apply one external field. Associated with that external field, we have a quantity. That quantity is magnetic intensity H, whose other name is intensity of magnetizing field or force. So that is the meaning of H. We'll again talk about this H later on. Now understand. Actually, you tell me. Yeah, okay. Actually, tell me. When you apply external field, that means when you apply H, what body do? What happens in the body? Yeah, body develops magnetism. Yeah, if you apply, this is what I'm saying you now, every body has magnetism, but without external field, it will not show magnetism. So what happens when you apply external field? Now body develops magnetism. Body gets some magnetization. So from there, we'll be talking about one quantity. You write intensity of magnetization. You see the name is telling you everything. Intensity of magnetization. Intensity of magnetization, and we represent this by capital I. Intensity of magnetization. You write, it is associated with intensity of magnetization. It is associated with magnetism which is developed in a body. It is associated with magnetism which is developed in the body under the effect of, it is associated with magnetism developed in a body under the effect of applied external field H. Under the effect of applied external field H. Under the effect of applied external field H. Now understand, again I will talk from the beginning. Be focused, this will give you idea. Then only you'll be able to do the questions from here, because things may become complicated slowly and slowly. So understand, I will simply say, sir, everybody has magnetism, but we cannot see that magnetism. If you want to see the magnetism in the body, now you have to apply external field. Associated with that external field, come on, tell me which quantity is associated with that external field. Which quantity is associated with that external field? Yeah, H is associated with external field. You tell me, due to H, what happens in the body? What happens in the body due to H? Body develops magnetism. Body develops magnetism. So there we talk about intensity of magnetization, capital I. Magnetic intensity or intensity of magnetizing field or force related with external field is H, and due to H, body develops magnetism. That is our intensity of magnetization. Now understand one more thing. Achha, what is meaning of magnetization? Body will develop magnetism. What is meaning of that? Magnetism means body will develop dipole moment. Actually, magnetism means what? Magnet means what? Magnet means magnetic dipole. You write this point. Body develops magnetic moment. Body develops magnetic moment. And now see what is value of I. So always remember your I, intensity of magnetization. Are a body develop magnetism na, that means body develop magnetic moment. So intensity of magnetization is nothing. Intensity of magnetization is simply magnetic moment. Magnetic moment developed by the body per unit volume. This is your intensity of magnetization. Magnetic moment developed per unit volume. If you want, you can write this as magnetic moment capital M volume V. Or if you want, you can write this magnetic moment as M into 12. You have studied about this magnetic moment M into 12, and volume you can write area into 12, area into length. So from here you can write, from here what will happen, from here you can cancel 12. So this will become M by A. M by A. M means pole strength. M means pole strength. From here we can say what will be M. Sir, M means pole strength. So pole strength upon area. Area means which area? We talk about cross sectional area. First you write this. So when you apply external field, associated with that external field we have H, that is magnetic intensity. And due to external field, body develops magnetism. Associated with magnetization of the body, we have intensity of magnetization, that is I. And this I is nothing. This I is the magnetism developed per unit volume. That is magnetic moment developed per unit volume. That is M by V. Or further, you can write pole strength upon cross sectional area. M by A. Chunky baat. Yeah, I'm giving you time of 10 seconds. Come on, see all these both results, both quantities. Achha, I will ask you one example. You tell me one example. Achha, when you are in class, everyone is present in the classroom. Achha, if I ask you what is the net study of all the students? Some people study, some people laugh, some people cry, some people dance, some people sleep. So net study is 0 now. That means you don't have any magnetism. Understand? But when teacher comes, teacher behaves as H. Teacher behaves as H, external field, which is coming. And due to H, you get some study. Are you getting the idea? Yeah. So if I come to your class, who I am? Don't say, sir, who I am? I am H. Who are you? You are I. Yeah. Okay. H means human. Yeah. Conical pendulum. Yeah. Okay. No problem. So this is how we talk about. So this is how these quantities are associated. Achha, you tell me now. Third quantity I am going to define. You tell me. Then I will talk about the third quantity. You tell me. Achha, Achha, does this H and I will be also related? Does H and I will be related? Sorry, if you apply more external field, more magnetization will happen. Understand, this H and I will be related. Are due to H only I is coming now. So if your H will be more, I will be more. Yeah, always remember both will be directly proportional. And there we talk about one quantity which is known as magnetic susceptibility. You write magnetic susceptibility. Magnetic susceptibility, which we represent by Xi. Which we represent by Xi. You write, it is a quantity which relates I and H. It is the quantity which relates I and H. It is simply ratio. It is a quantity which relates I and H. This is what I was telling you, I and H will be related with each other. So it is a quantity which relates I and H. It is simply ratio of I and H. So always remember your Xi is defined like this. Xi, magnetic susceptibility, will be equal to intensity of magnetization upon magnetic intensity. Xi will be equal to I by H. Now from here, if you see, some questions are asked like this also. They will give you IH graph. And they will say you IH graph is a straight line. They will say you, what is this slope? Slope of IH graph. Slope means tan theta. Tan theta will represent, come on, tell me. Yeah, tan theta will be I by H, perpendicular by base, that is I by H, and this will be equal to your Xi. This will be equal to your Xi. You can write this, come on. And I'm giving you time of 30 seconds. See all these quantities, see all these three quantities, we'll use them. See all the quantities. First, I will ask the question. You tell me which quantity is associated with external applied field. Which quantity is associated with the external applied field? Yeah, H. Yeah, H. Okay, no problem. Magnetic intensity or intensity of magnetizing field or force, which we represent by H. So which quantity is associated with magnetic field developed in the body? I. I is associated with magnetic field. What is another formula for I? I will be equal to magnetic moment per unit volume, M by V, capital M by V, or pole strength by cross sectional area. Pole strength by cross sectional area. Okay. Now you tell me which quantity represents which quantity relates I and H. Yeah, that is Xi. Xi will be equal to I by H. What is slope of IH graph? What is slope of IH graph? Xi. Yeah. Okay. Magnetic susceptibility. Yeah. Okay. No problem. Now understand. Now understand how we'll be talking about. Okay. So this is how we are talking about all these things. Yeah. Now I am going to tell you same thing in another manner. Now I will tell you, till now I have never told you magnetic intensity. I said you it is associated. I did not say this is the formula for magnetic intensity. So be focused, understand how I will be talking. Same thing I will tell, but now I will give you real example where this H will also come, where this I will also come. So be focused, very, very important part. Just see here, how we'll be talking about. For example, assume I have a body. I'm having a body. This body can be made up of any material. This body may be paramagnetic, maybe ferromagnetic, maybe I don't know, but I know, sir. If you apply some magnetic field, sir, inside body one magnetism will be developed. What will happen? Just here, I'll be saying, I don't know, sir, which body is this, what is this property, I don't know, but I know, sir, if you apply some external field now, inside body some magnetic field will be induced, or you can say inside body some magnetic field will be developed. And net magnetic field will become, if I talk about net magnetic field, net magnetic, one I applied, one body developed. So net magnetic field will become, so B net will become B applied plus B induced. This is the net magnetic field. And this net magnetic field is also known as magnetic induction. Sometimes they will use these words. This B net is also known as magnetic induction. Magnetic induction means net magnetic field. Now always remember, now be focused, understand. This B applied, I told you associated with applied field, you have H. So this B applied by mu naught is known as H. Applied magnetic field per unit permeability. B applied by mu naught is known as H. And this B induced by mu naught is known as I. Is known as I. First write this, come on. Associated with applied field per unit permeability is H. Induced field per unit permeability is I. And net magnetic field is known as magnetic induction. What is the net magnetic field in the body? That is magnetic induction. Now understand. Okay, sir, we understood. So this is the net magnetic field, sir. Net magnetic field you are saying as magnetic induction. Now be focused. Understand how we'll be talking about some very, very important things I'm going to derive from here. Just see. That means I will simply say, sir, let's represent net magnetic field. Net magnetic field means magnetic field now. So I will assume I will represent magnetic field by B. I'm going to represent net magnetic field simply by B. So B will become B applied, you know, now you can find B applied from here. Now B applied will become, you know, B net will be coming as sir B applied plus B induced. Okay, no problem. Sir, B applied you can write, sir. B applied will be coming as mu naught into H. Look at there. B applied by mu naught was H. So B applied will come mu naught into H. And B induced will come mu naught into I. So from here you can find magnetic induction in the body if H and I is given, that is mu naught into H plus I. This is one formula from where sometimes some questions are asked. First you write this one, but not very important. More important part I will talk after this. Yeah. So B applied, we can write mu naught into H. B induced, we can write mu naught into I. So we'll put there, we will get. Now understand where I am trying to move you. That is very, very important. Next, I will simply say, sir, we have understood this. But can you relate Xi here? Can you relate magnetic susceptibility Xi? I can relate. I will simply say, sir, I know Xi will be coming as I by H. So from here, I can write as Xi into H. And I will put that I here. Once you put that I here now, you will start getting B as mu naught into H plus I. What is your I? I is Xi into H. Now be 100% focused. Something very important I am moving towards. I'll be simply saying that means, sir, from here you can write. Again, you can take H common. So this will become mu naught into 1 plus Xi into H. And this quantity which you are seeing here now, this quantity is known as permeability of a medium. Mu naught is permeability of vacuum. This quantity mu naught into 1 plus Xi, this quantity is known as permeability of a medium whose value is 1 plus Xi into mu naught. And this result becomes finally B will be coming as mu of medium into H. This is how permeability of a medium is defined in the terms of magnetic susceptibility. First you write this and you have to remember that result. So many times questions has been asked from that result. They will give you the value of Xi. Mu naught, you know, 4 pi into 10 to the power minus 7. Answer will come. Last year only NEET question was asked. this mu naught 1 plus xi into mu naught is defined as permeability of a medium. If its magnetic susceptibility is xi, you can write permeability of the medium as 1 plus xi into mu naught. Now understand one more thing I will tell you. One more thing I will tell you. Acha, if you remember, in electrostat, I was saying you na, epsilon of the medium can be written as epsilon r into epsilon naught. Do you remember that? Same thing we can do here also. Epsilon of mu of a medium can be written as mu r into mu naught. This mu r is known as relative permeability. This is known as relative permeability. There it was relative permittivity. This is now relative permeability. Now from here, if you use that, you can get value of mu r also. Mu m you can write, mu of a medium you can write. In the same result I'm talking about. Yeah, I'll be simply saying, I can write, sir, I can write here, mu of the medium I can write as mu r into mu naught. This will be coming as 1 plus xi into mu naught. So mu naught will get cancelled. Relative permeability of a medium will come 1 plus xi. You can remember anything. You can just remember mu r. Mu r is 1 plus xi. Mu r is 1 plus xi. And mu of the medium, you know now, mu r into mu naught. Mu r into mu naught. You will get mu of the medium. If mu r will be as 1 plus xi. So come on, tell me what is relative permeability of a medium. Mu r will be equal to 1 plus xi. Yeah, 1 plus x you can type. For xi, if you want to type, you can type x, no problem. Yeah, 1 plus xi, 1 plus xi, 1 plus xi. Achha, what is permeability of a medium? If xi is given, can you find permeability? If xi is given, can you find permeability? Yeah, mu r into mu naught. Mu r is 1 plus xi. So 1 plus xi into mu naught. 1 plus xi into mu naught. Yeah, I will give you one question. Come on. And what is value of this mu naught? Bolo. Do you remember value of mu naught? Yeah. 4 pi into 10 to the power minus 7. In exam, you have to put the value of mu naught. You write the question, come on. Write one previous year, last year only question was asked. You write that question, come on. You write. Find permeability of a medium. Find permeability of a medium whose magnetic susceptibility is, find permeability of a medium whose magnetic susceptibility is 99. Find permeability of a medium whose magnetic susceptibility is 99. Yeah, Prashanti, very good. Yeah, Diksha, very good. Put the value of mu naught also, Baba. Lazy students, all are giving the terms of mu naught. Yeah, boys are also giving the terms of mu naught. Put the value. I will simply say mu of the medium is, sir, mu r into mu naught. Okay, mu r we know, sir. 1 plus xi. So 1 plus xi into mu naught. Xi is given 99. So 1 plus 99 into mu naught. 1 plus 99 is 100. 100 mu naught. But this will be not present in your NEET exam in option A. Nilima, correct? Very good. 100 mu naught we know, sir. 4 pi into 10 to the power minus 7. So final answer will come 4 pi into 10 to the power minus 5. This is the answer. Sabki baat. You write one more previous year NEET question. Yeah. Okay, Alisha. Yeah. Asliya. Correct. Yeah. No problem. Yeah. Write the next question. Come on. You write. A material is found to have magnetic susceptibility of 999. Find its relative permeability. A material is found. Oh, Survi, very good. Sneha, very good. Patnaik, Prashanti, everyone is getting. Harika, yes, everyone is getting. Yeah. Okay, very good. Teja, correct, very good. Charisma, I think everyone will. Such very simple questions. Sir, you want mu r na? Xi is given mu r, I know, sir. 1 plus xi. So 1 plus 99. This is very tough. 999. How to add? Very tough. Yeah. So this will give us 1000. So this is how very simple questions are asked. I'm giving you time of 15 seconds. Come on, see all these results. Come on. We'll move to the next part. Very simple, sir. Mu r will be 1 plus xi. If I know mu r, I can find mu of the medium, mu r into mu naught. So mu r is 1 plus xi. So mu of the medium will come, sir, 1 plus xi into mu naught. And B will be equal to mu of medium into H. And mu of medium we know, sir, 1 plus xi into mu naught. Everything is very simple, Baba. So this is how we have talked about one part. Now we'll be moving towards next part where these things will be used. Why I told you all these things? Because these things are also asked and their use will come when we'll study different type of material. You write types of material. Types of material. Can you tell me how many types of material we have? Yeah, we study about 3 types of material. What are those 3 types? Come on. Come on. Para, dia, ferro. Yeah. Para, dia, ferro. Paramagnetic material, diamagnetic material, ferro. Oh, PDF. Oh. Yeah, SPDF you write na, SPDF. So para, dia and ferro. Okay. Yeah. Ooh. Okay, okay, no problem. Yeah. Okay, now be focused. Be focused. Understand. Yeah. Anti-ferro we no need to study here. Yeah. Okay, we talk about only para, dia, and ferro. Now be focused. Understand. This here how we'll be talking about. Acha. Okay. Acha. Just now I was saying you now some idea I will give you. Be focused. Understand. Some concept first. Understand. Just now I told you now everybody will have magnetic property. Now you'll be thinking, sir, why everybody has magnetic property? What is the reason? Always remember, everybody has magnetic property due to electrons. Understand what I am trying to tell? Always remember, everybody possesses magnetic property due to atomic current. Actually, what happens if you look at anybody now, everybody, not free electrons. Come on, be focused, understand. Always remember, everybody will be made up of atom. In atom, electrons will be there now, and you know those electrons will be moving on circular path around nucleus, and you know when electrons will be moving in circular path now, they will generate current, and when current is there, magnetic field is there. So always remember, sole reason behind magnetism of any body is atomic current. Atoms produces current due to electrons, and due to that current, body has magnetism. You write, everybody has magnetic property due to atomic current. Everybody has magnetic property due to atomic current generated by revolving electrons. Generated by revolving electrons around nucleus. Everybody has magnetic property due to atomic current generated by electrons revolving around nucleus. But without external field, these atomic currents are random. But without external field, these atomic currents are random. Hence, body cancels its magnetism. Because you know some electrons revolve clockwise, some electrons revolve anti-clockwise. So some electrons give plus I, some electron gives you minus I. So net current becomes zero. So net magnetic field becomes zero. Everybody has magnetic property due to atomic currents generated by revolving electrons around nucleus. Without external field, these atomic currents are random and they cancel each other. Up to this, okay? Everyone understood? Yeah, okay, no problem. Now keep on understanding. Keep on understanding how we'll be talking about. Now I will tell, yeah. Yeah. Hence they will cancel each other. Okay, now understand how we'll be talking about. So, okay, sir. Everybody has magnetism, sir. That means everybody will have magnetism due to atomic current. Who is generating this atomic currents? A revolving electron. Due to revolving electron, current is coming. Due to current, magnetic field is coming body. But initially what will happen, these currents will be random. So net magnetism is zero. But when you apply external field, body develop, this currents come in one direction and body develops magnetism. And based on this, we have three types of material. You write diamagnetic material. We'll talk about different properties of diamagnetic material. So first you tell me which type of material shows diamagnetism. Which type of material? You have studied in chemistry, na? Which type of material shows diamagnetic property? Yeah, paired electron. Paired electron. Yeah, paired electron. You write. Come on, you write. Yeah. Okay. You write. It is property of paired electron. It is property of paired electron. It is property of paired electron. It is property of paired electron explained by, this is very important part, explained by, it is property of paired electron explained by Lenz law. I think you have studied about Lenz law. Actually, Lenz law is used to explain this diamagnetism. Paired electron means what? If it is paired electron, then no, that paired electron phenomena is explained by Lenz law. So always remember, first thing, if a body is showing diamagnetism, that means body has paired electrode. And how we explain diamagnetic property? We explain diamagnetic property with the help of Lenz law. Lenz law we'll study in our chapter, yeah, EMI. In EMI, we'll be studying about that Lenz law. Okay, no problem. Now understand. You write the next point. Come on. You write, in these type of materials, if you understand one material, rest you'll understand very fastly. In these type of materials, magnetic field induced, in these type of materials, magnetic field induced is opposite to the applied. Just now we studied now, one applied field will be there, one induced field will be there. So this type of material, induced field is opposite to the apply. If you apply along x-axis, they will develop magnetic field opposite. They will develop across negative x-axis. So this type of material, induced magnetic field is opposite to applied. Hence, net magnetic field reduces. Hence, net magnetic field reduces. And these materials suffer. Hence, net magnetic field reduces. And these materials suffer weak repulsion. And hence these materials suffer weak repulsion. Net magnetic field reduces and these materials suffer weak repulsion. A reduced field is opposite to applied. Nah. So due to that, what will happen? They will suffer repulsion. Hence they suffer weak repulsion. And they always try. And they always try. And they always try to move from, and they always try to move from strong region of field to weaker region. In strong field, they will suffer more repulsion now. So that's why they will try to minimize the repulsion. So hence they always move from strong region of magnetic field to weaker region of magnetic field. I'm giving you time of 10 seconds. Just have a look about this diamagnetic material. Again, I will talk about. Very, very important part. Theoretical questions are asked from here. Previously, NTA removed this topic, but now again they have added. Yeah, this is a correct problem. Yeah. Be focused. Again, I will talk about, just see what are the points you have to keep in your mind. Be 100% focused. Understand. First thing, you always remember. Sir, first thing, sir, which type of material will show diamagnetism? Which type of material will show the materials which will have paired electron? Sir, paired electron, but who will explain that due to paired electron we will get diamagnetism? That explanation comes with the help of Lenz law. So diamagnetism is a property which paired electron bodies have, and that is explained with the help of Lenz law. This is the first part. Second part, sir, what will happen in the case of what happens in the diamagnetic material, sir? Actually, what happens in diamagnetic material, induced magnetic field is opposite. You have two options now. Either your induced magnetic field will be in the same direction. Same direction happens for para and ferro. But here what happened? Opposite. So induced magnetic field is opposite to apply. So tell me what will happen to the net field. Net field will increase or decrease? Net field will decrease. If net field will decrease, yeah, net field decrease. And since they have induced magnetic field opposite to apply now, they will suffer repulsion. They will suffer repulsion. You tell me, if you suffer repulsion, repulsion means go away, go away. That means it will go away. If it will go away, that means it will go from higher field, more magnetic field, a strong magnetic field, to weak magnetic field. That is the meaning of going away. That is the meaning of repulsion, so that it can decrease the repulsion. Everyone understood? Come on. Yeah, okay, very good, very good. Yeah, this is one way to talk about diamagnetic material. This I am talking about diamagnetic material in one way. Now we'll talk in another way. In the terms of permeability, I will talk about. In the terms of magnetic susceptibility, I will talk about. Be focused. This is more important. Just here. What I said you, in diamagnetic material, net in the diamagnetic material, sir, induced magnetic field is opposite now. So due to opposite, net magnetic field reduces. So I simply say, sir, in diamagnetic material, net magnetic field will be less than vacuum. If nothing is there, then vacuum. But what is happening in diamagnetic material? Your one magnetic field is induced, due to which net magnetic field decreases. So B net will be less than B of vacuum. Now I'll be simply saying that means B net, if magnetic field in diamagnetic material is less than vacuum, that means mu of diamagnetic material will be less than mu of vacuum. Mu will be less than mu naught. If magnetic field less, permeability will be less now. So magnetic field for diamagnetic is less, that means permeability is less. If mu is less, you can say, sir, mu I can write as mu r into mu naught. So mu r into mu naught will be less than mu naught. That means from here mu naught you can cancel. Don't think here 0 will come. Here 1 will come because product is there. So from here I will say mu r will be less than 1. This is the value of relative permeability for diamagnetic material. And you know this mu r is also equal to 1 plus xi. If your mu r is less than 1, that means 1 plus xi is less than 1. That means from here again 1 will get cancelled. Now you'll be getting xi less than 0. Xi less than 0 means your xi will be negative. Xi will be negative. For diamagnetic materials, magnetic susceptibility will be negative. Negative, less than 0 means negative. First write this. See how things are coming. Our induced field was opposite na, so net field is less na. That means permeability is less than vacuum na. So mu is less than mu naught, and mu you know na, mu r into mu naught. That means mu r is less than 1. If mu r is less than 1, you know mu r is 1 plus xi. That means xi is less than 0. Less than 0 means xi is negative. But you tell me, what is meaning of negative xi? Does negative xi means minus 10, minus 20, minus 50? Less than 0 means negative. Less than 0 means negative. So can I take negative means, can I take minus 4? Can I take? No. Always remember there is a limit. Yeah. You cannot go below that. Always remember, sir, xi is less than 0. For diamagnetic materials, sir, xi is negative. But that negative value cannot be less than minus 1. Always remember minimum possible value of magnetic. So always remember its value of your magnetic susceptibility. For diamagnetic material, your xi will be less than 0. but it will be always greater or equal to -1. It will be negative, but it will be not less than -1. It will be never reached. Minimum value will be -1. And when xi becomes exactly equal to -1 now, such bodies are known as perfect diamagnetic. Perfect diamagnetic. And this perfect diamagnetic example is superconductors. And this was explained by one scientist, yeah, superconductors, okay, whose name was Messner. So this is also known as Messner's effect. Just for show, it will not be asked in your NEET. So don't think xi is negative, sir. So -5 I will take, -10. No, there's a limit of that negative. You cannot go below -1. So minimum value of xi is -1 for perfect diamagnetic materials. If someone says xi equal to -10, possible? Ledu. Sir, minimum is -1. You cannot go below it. Yeah, so this is how we talk about, yeah. And if xi becomes equal to exactly -1, that is perfect diamagnetic material. Achha, do you want to know why xi is the minimum value is -1? Why it cannot become less than -1? I'll just give you idea.